Here we go. We are looking at last night's homework. Today is the 3rd of May. It's a Tuesday, and we're seeing how to work problems from modern chemistry, page 622. So we have an equilibrium reaction up top, and one of the things that we're looking at is correcting a problem that I made for you on Monday. And that is, I didn't understand when you see for instance, the 42 kilojoules here on the right, I took that as delta H, and it is not. What we are finding out that we need to do is simply replace kilojoules, whether it's on the right or the left, with the word heat, and then that is something that's familiar to everyone, and that works out just great. So I'm going to work all three things. Basically, what we're being asked to do in this problem is figure out how to get the most product out of a reaction. Very, very important to manufacturing. Okay, and because I was in manufacturing, I understand that exceptionally well. I was a manufacturer for 12 years, and I knew that if I was going to put food on the table at home, I was going to have to make a profit. And so I wanted to make sure that the price at which I sold was high enough that I could actually make a profit. And I had a certain amount of dollars that I had to make each month to be able to support my family. So this is like giving, for chemistry, this is like giving a chemical manufacturer a guidebook to how to construct his chemical manufacturing, or how to carry on the reaction to get the most product using the Le Chatelier principle. So what Le Chatelier does is he says, okay, you just gave me some stress to this reaction. You added some copper ions, and that's what the up arrow is all about. And so Le Chatelier wants to reduce the amount of copper ion in the water. And so he can only do that by taking copper and combining it. Here's the copper ion, here's the ammonia. Copper and ammonia being combined reduce the amount of copper and the amount of ammonia and make the copper ammonia complex, which is an ion. And it also has exothermically produced heat because the kilojoules is on the right side. And so we're going to experience a right-hand shift by combining the reactants to make the product and produce heat. So LeChat is concerned only with, not the heat on this one. We're just worried about concentration. So the concentration is going to go down very nicely. I've been talking about the heat and I got sidetracked there. Okay, let's look at the next one. When the pressure is up, we're working on a whole different set of rules. And if you don't have this particular sheet in your possession, you might want to take a look at it right now in the video and perhaps copy that down, and that will give you a great guide to how to deal with Le Chatelier problems. The first thing that they always tell you about is a stress, and that becomes the stressor, and there's three different kinds of stress: concentration, volume, and heat. And we're doing all three of those several times. So go back and do that if you like, if you're watching this video. So let's go down now, and our last thing is the heat. And what happened to my, oh, here we go. Back up here. So we're going to finish up the pressure now. Pressure, LeChat always wants to do the exact opposite of what the stress is. And the first thing that we always put in a Le Chatelier problem that uses my little thing of how to deal with Le Chatelier problems. And we've got stress, what Le Chatelier wants to do. It's always the opposite. And the Le Chatelier, what he does. And by doing what he does, he creates a shift to the right or to the left. And that's pretty much the end of it with most Le Chatelier problems. But here we're doing something, we're dealing with pressure now. So we're going to go to the side with fewer moles because that's how you deal with pressure, and that's what you find out when you use this sheet. So we're going down here again now, and we're going to see that by going to the side with fewer moles, we have 1 mole for copper ammonia complex, and then we have 4 plus 1, which is 5 moles of copper plus the ammonia. And so 5 moles becomes 1 by moving to the right. So that's a pretty strong shift, and it produces heat. But heat's not part of this process right now. So there's our right shift for that guy. So if we go now to the last thing, heat, yesterday I would have told you to start with heat up, but now I found that heat should have gone down. And by putting heat down, that means that the stress is we're removing heat, like we take the reaction mixture and put it in the refrigerator, and now heat is being produced. But how is LeChat going to produce that heat? He can't do anything but shift left or shift right. So he shifts to the side, the same side that the heat is on. And that will also create a right shift. So all of these results happen with these stresses. So as a manufacturer, I would want my copper ions to be in there heavy duty. The more I can get in there, the better. Because when I raise the concentration, LeChat wants to use the copper ion to make the copper ammonia complex. When he does that, he inadvertently creates heat as well. But he reacts in this line to the concentration of copper ions. In this line, where we're talking about pressure, he's simply reacting to pressure, and pressure is always directly proportional to the number of moles that are in the mixture. So if we can reduce the moles in any way, that's why we talk about the side with fewer moles. If we can reduce the moles in any way, that will help produce a stronger reaction that will produce more product. And then the heat, we want to have this reaction going on in a place that's cold, because that's going to remove heat. That will be a stress to this particular system. So if the heat is down, LeChat's going to try to produce more heat, and like I said before, when he produces this stuff, by combining these two with a right shift, he will also produce heat. Okay, now I'm going to start calling on students, and we'll see if we really understand what's going on here. So we'll be going to, in the first reaction, the first stress is going to be hydrogen iodide is going to be added to the solution. So if hydrogen iodide is added to the solution, Alan, what's going to happen? What is LeChat going to do? Or what does he want to do? Okay, he's going to combine H2 plus I2, and that will make more. Okay? That will get the HI down. That will get the HI up. Let's see. The stress is up. The HI wants to go down. And to get the HI down, what do we have to do? What is LeChat going to want to do? Break it up. Very good. So he's going to break up or break apart the HI. And by so doing, he will create that right shift that you see over here. So basically, he's breaking up this guy, but it requires heat, and we'll talk about that when we get to the heat line. But we deal just with concentration when we're given a species like HI or hydrogen or iodine. Yes?
So isn't the stress just iodine?
No, the stress is not iodine. The stress is HI. Hydrogen iodide. And so to get that hydrogen iodide down, because we added more, we need to, LeChat, the only thing he can do to make more hydrogen iodide, or to bring the hydrogen iodide down, is to break apart the hydrogen iodide. Okay? And if he breaks apart the hydrogen iodide, that will make more hydrogen and more iodine. And we're trying to find out how to get more product. And I believe the underline in the problem set was under the hydrogen. Okay, I don't have the sheet in front of me right now. Okay, that was 15C. 15C, oh, it was iodine. Okay. So we're trying to get more iodine. How are we going to produce more iodine? Well, when we produce more iodine, we'll also produce more hydrogen. Because when you break up hydrogen iodide, it's not going to give you just iodine. But LeChat will help you with this by shifting to the right. Okay, so let's go down here, and now let's deal with the heat issue. The heat issue is on the third line of this chart, and this tells you how to deal with heat. So if heat is up, there we go. Let's get the reaction showing. There we go. If heat is up as the stress, and we go heat down, Anthony, Muriel. Okay, so Anthony's going to go ahead and do this one. If the heat's down, what does LeChat want to do? After he gets the heat down, or when he wants to get the heat down, now what is he going to implement to make that heat go down? Okay, yeah, he decreased the temperature, but how does he get the temperature down? Where's the heat in the balanced equation? Left or right? Okay, so this is an endothermic reaction. So how does he get the heat down? How does he use up the heat? That will take the temperature down. Does he put heat and hydrogen iodide together to make hydrogen and iodine? Or does he use heat or does he take the hydrogen iodide, or the hydrogen and the iodine, and make more hydrogen iodide and more heat? Which way does he want to go?
I think he puts the two together and he makes more hydrogen.
Puts what two together?
Hydrogen and iodide.
You're going to put hydrogen and iodine together, and you're going to make less heat.
More heat.
Okay. What LeChat wants to do is to reduce the heat. So what does he have to do? Do you have the chart? Okay, look at it. If heat goes down, heat is up as the stress, so we're on the top line of the heat part, right?
Yeah.
Okay, so if we're on the top line of the heat part, we want temperature down, right? And that we're doing that as heat down. And now, how does he accomplish this?
Release less heat.
Yeah, but how?
Shifts it to the opposite side of the heat.
Okay, which side is the heat on?
On the left.
Very good. So, what is he going to do?
And move it to the right.
He's going to shift to the right. Yep. I don't think I talked through the pressure thing. Let me go back to that just real quick here. The pressure being down, we're going to the side with fewer moles. Okay, we have 2 moles over here and 2 moles over here. One for the iodine, one for the hydrogen. And then there's 2 moles here. It's all hydrogen iodide. When we have that situation, we aren't going to have a shift. Because if LeChat shifts it to the left, he's trading 2 moles for 2 other moles. If he shifts it to the right, he's trading 2 moles of hydrogen iodide for 1 mole each of hydrogen and iodine, and he winds up with 2 moles again. So there's nothing that Le Chatelier can do to help us make more money by adjusting the pressure, because there's a different number, or same number of moles on both sides. Okay, let's go down to this reaction. This one will go to, oops, I want to put that back. Yeah, this one will go to, there we go. There we are. And let's move this up so that we're concentrating on just one reaction. There it is. Okay. Marielle, what do you say? What does LeChat want to do here? Okay, concentration of hydrogen went up. What does he want to do? He wants it to go down. How is he about to do that? What? Doing what to HCl? Raising the amount of HCl. Will that bring the concentration of HCl down? Oh, you want to break up the HCl. Okay, that's fine, but you're not going to, you shouldn't concentrate where you have two reactants. You should be thinking about the combining. Okay? So, yes, that will break up this, but it will also break this up. And you see they're rearranged over here. We produce chlorine gas from the chlorine and the hydrochloric acid, and we wind up with water by producing the hydrogen and breaking up one oxygen for each four of the hydrogens that come into this reaction. So we wind up with two oxygens, two chlorines, and two waters. Okay, so the hydrogen chloride is going down now, and how did we do that? What does LeChat do to make that happen? He's combining, and what does that give us as a shift? What? To the right, because when you combine hydrogen chloride and oxygen, that means that you are getting rid of those and you're going to the other side. And I like seeing two reactants and two products because the combination could happen on the left or it could happen on the right. Right? Okay. So that's that guy. Let's go down and now let's look at heat. You'll notice that I have heat going up as my first shot, and that took us the wrong direction. It didn't give us the right shift. So if heat goes up and we change it to heat goes down, then LeChat will also do the opposite thing. And when he does that, he's going to the side that's the same side the heat is on. That's how you get more heat. And so you can see here, my original answer would be wrong because we're trying to get a right shift, because that puts more money in the pockets of the manufacturer owner, the owner of the manufacturing company. Okay? So that's what we're after. Okay, here's the next reaction, and I think this is the last one. So everybody at home will be able to see all of these talked out except the first one, which we did yesterday. So in this reaction here, we'll let Parsa, not here, and Michael, you get to do this one. So we are doing the PCl up or PClI5, okay? And so that's phosphorus pentachloride. So what does LeChat want to do?
He wants to get less PCl5.
You bet. He wants to reduce it. And how's he going to do that?
He combines the PCl5 with reduced.
Okay, you can talk about it that way. Or in this case, because this really doesn't get combined other than to use up the energy from it, in this case, you could say break it apart, okay? Which is, I think, the way I described it. And what shift does that give us? Right. It does give us a right shift. Cool. And so that is going to help the manufacturer make more money. And pressure. Okay, I tested to see if pressure would go up and make a right shift, and it didn't. So, Neville, what happens when we put the pressure down? What does LeChat want to do? You bet. Okay, and now that he's got it going up, how is he going to make more pressure? Great. Okay, how many moles do we have on the left side? See, kilojoules don't count for moles. What's the coefficient of phosphorus pentachloride? What's the coefficient? That's the subscript of the chlorine. Okay, you're looking at the wrong number. Good. So we have 1 mole on the left. How many on the right? How many for PCl3? What's the coefficient? Okay, what's the coefficient of chlorine? Okay, how many moles on the right? Good. Okay, so to get more pressure, which side does he go to? And because? More moles. Okay, go to the side with fewer moles will make the pressure, oh, no, with more moles. Then see, this was my original. So I'll go to the side with more moles to up the pressure. All right, so moles up, that means pressure's up, and which way are we shifting? Indeed. Okay, so I didn't cross this out yet. You need to see that, because that's the wrong way to go. We don't want that, because that won't help us make more money. Won't help us make more product, which won't help us make more money. Okay. Next thing goes to John. You're on. Oh, it rhymes. Okay, John, what do we do when the heat's up? Or what does LeChat want to do when the heat's up? He wants it to go down, indeed. How does he get the heat down? I'm sorry? Going to the side with the heat? Okay, good. You can say that as go to the opposite side of the heat. Okay? And what kind of shift does that give us? Right shift? What? Yeah, right. Correct. Absolutely good. I hope you found this helpful. Thank you for watching. See you.